Let's take a closer look at the big picture, the basic configuration of most weaving machines. The basic functions of a loom are shedding, filling insertion, bead up, and warp control. The flow of the yarn in the loom is easily seen from the illustration. The weaving process starts with the sized yarn coming off the loom beam in a single sheet or layer of yarn. The yarn then proceeds over a tension or whip roll that is designed to maintain a constant level of tension on the warp yarns throughout the entire weaving cycle. Each yarn then travels through its own drop wire that serve as stop-motion detectors. When yarn tension drops too low, or when the yarn breaks, the metal drop wire will complete an electric circuit and the loom will stop. Next, each warp yarn then passes through its own heddle that is suspended in the harness. The heddle has an eye through which the yarn passes and allows for exact control of each yarn. The harnesses control the raising and lowering of the warp yarns. The yarns then proceed through the dents of the reed. The reed is a comb-like device that maintains the position of the warp yarns as well as performing the beading up of the filling yarn into the body of the cloth. The point where the yarn is beaten up into the cloth is called the fell of the cloth. This is the transition point where the yarn becomes fabric. The cloth now winds over the take-up roll, sometimes called the sand roll or press roll, which, when combined with the let-off of the loom beam, controls the number of picks per inch in the fabric. Finally, the cloth is rolled onto a cloth roll. Shedding is the process of creating a path across and through the warp yarns by raising some warp threads by their harnesses and leaving other yarns down by keeping their harnesses in the down position. There are three methods of creating a shed: cam shedding, dobby shedding, and jacquard shedding. Cam shedding is the most basic of shedding motions. It uses profiled cams to move the harnesses up and down. Cam looms usually have 6 to 8 harnesses. Cam looms are best suited for simple weaves like plain weaves, basic twills, and satin weaves. Pattern changes require changing the harness cams, which is a simple process. Dobby shedding uses an electronic or mechanical device to select and move individual harnesses. Up to 28 harnesses can be used to weave complex twills, satins, small geometric figures, and pattern stripes. The jacquard head motion is the most complex shedding system. It is named after its inventor, Joseph Marie Jacquard, who developed the system in 1801 to be used on hand looms. The jacquard has advanced significantly since then, but it still works on the same principle today. Jacquard shedding exhibits control on each individual warp yarn independent of all other warp yarns. Up to 12,000 warp ends can be controlled. These systems can employ mechanical or electronic devices to actuate the warp ends. Design capability is virtually unlimited. Pattern areas can equal the width of the fabric and are almost unlimited in the length. Fabrics made on jacquard looms are normally more expensive because of their complexity and slower weaving speed. There are no harness frames on this style of loom. Each end is activated independently, being controlled by its own harness cord from the jacquard head. The harness cord is attached to a heddle, which is pulled down by a spring in most cases, but in some of the older and slower models, weights are used to pull the heddles down to achieve the pattern.